Good morning, students. In the last class, we have been discussing about this transient heat conduction. Today, we will solve few more problems, and today we are going to solve especially the practical case problems. So, right. So here goes your question. In this question, what he has given a load of peas, means a kind of batani we call it. In Telugu, we call it batani, or in Hindi, we call it as batani. So there are so many batanis, and it is a load at a temperature of 25 degrees centigrade is to be cooled down to room at a constant air temperature of 1 degree centigrade. See, this is somewhere in cold country or cold place. And the first question, how long the piece will require to cool down to 2 degrees centigrade when the surface heat transfer coefficient of the piece is so and so. So let us solve the first question first and then move to the second one. Let's write given there is a piece, load of piece, and then the temperature is given as 25 degrees centigrade, and temperature of the atmosphere is given as 1 degree centigrade. So this T 25 degrees centigrade will be T naught. That is initial temperature. And then you have 2 degrees centigrade. So this is the temperature of time T. That is 2 degrees centigrade. Simply we'll call it as T. And H is given. The H value is 5.81 watt per meter square Kelvin. And using this, he is asking you to find out what is the time in the process. For that, at the end, you can also see this part. The piece are supposed to have an average diameter of 8 mm. That is, what he is saying is, he is asking you to consider it as a sphere. Since he is asking you to consider it as a sphere, you can take it this way. So from this, you can get the diameter is equal to 8 mm, and the density rho is equal to 750 kg per meter cube, and the Cp equal to 3.35 into 10 cube joule per kg Kelvin. So that's what is given. And first you have to check whether it is a lump system or not. In any given transient problem, your aim is to check whether it is a lumped system or not. For that, you have to find out the BAT number. The BAT number is equal to HLC by K. You have H with you. This is your H, and K value. K value is it given in question? K value. See, the K value is not given in this question. So obviously you have to forward without finding the BAT number itself. Okay. See, how can you solve the problem if the K is not given? If the K is not given, how do you solve to solve this problem? Because what you have in your formula, you have Biot into Fourier. This is what you are having. In Biot, you have HLC by K. In Fourier, you have alpha. In place of alpha, what I can write is K by rho Cp into T alpha T by LC square. I can write this K get cancelled. So this LC gets cancelled. So without K also, you can do the problem. So, so what we have here for Biot into Fourier is equal to H into 1 by rho Cp into T by LC. This is what you have. That's what Biot into Fourier value is. Here, you don't know what is the time value. Time you put it aside, and H value is given in question. It is given as 5.81. 5.81. And in the denominator, what you can write is 5.81 by rho. The rho value is given in question as 750. The CP value is given as 3.35 into 10 cube into the LC value also you should write. Now, what is LC value for sphere? You have to calculate it. So, how do you calculate it for the sphere? It is 4 by 3 pi r cube by 4 pi r square. Okay, this 4 pi, this one goes, this one goes. So, what you have is r by 3, that is d by 6. D value is given in question as 8 mm, 8 mm by 6. So 8 by 6 into 10 to the power of minus 3 meter is your LC value. What is 4 by 3? So we substitute it here. 5.81 by 750 into 3.35 into 10 cube into 8 by 6 into 10 to the power of minus 3. This one goes into T. So tell me what is this value? Biot into Fourier in terms of time. This is something you tell me.
1.77 into 10 power minus 3.
0.77 into 10 to the power of minus 3. Right. So that is Biot into Fourier. Now that you know this, you need to calculate what is the time. So the formula here is T minus T infinity by T naught minus T infinity is equal to e power minus Biot into Fourier. This is the formula. So the T value is given in question as 2 degrees centigrade and the T infinity is 1 degree centigrade. 1 by the T naught is 25 and T infinity is 1 again, e power minus of 1.77 into 10 to the power of minus 3 into T. So what is T? You have to calculate.
1.7 into 10 power 3.
Apply ln here. It is important that you apply ln. Tell me what is the time value?
1.79 into 10 power 3.
Really? It can't be that low, right?
See,
Second.
31.18 minutes.
31 minutes. You tell me in seconds.
1807.9 seconds. 9.
1807.96
1869.
seconds. 1869, huh? Tell me, 18? Yes, please tell me what is this value?
1869.
1869.4
4.
seconds. This is your time. So that completes your first question. So this is around 31 minutes. This is approximately equal to 31 minutes. We'll discuss about this little later. So that completes your first question. Let's move on to the next question, that is B. What is the temperature of the piece after a lapse of 10 minutes from the start of cooling? He's asking. So in this question, your temperature is not known, is considered to be not known, and time is considered to be known. So that is T minus T infinity by T naught minus T infinity is equal to e power minus biot into Fourier you have with you. Okay, in this T infinity is anyways 1, and T you don't know, you have to calculate it. This one is 25 anyways, it's given. So if you want biot into Fourier, it is 1.7 into 10 to the power of minus 3. See, this one I am using 1.77 into 10 to the power of minus 3 into time is given as 10 minutes in this question. This B question, the time is 10 minutes. 10 into 60 you have. So you can substitute into this one. So T is unknown. Calculate it.
49.4.
49.
9.12 degrees centigrade.
Okay. 9 point is okay. Temperature is 9.12 degrees centigrade. Good. So this is T minus 1 by 25 minus 2 is equal to e power minus 1.77 into 10 to the power of minus 3 into 10 into 60. So the T will be 9.12 degrees centigrade. Fine. So let's move on to the next question. This is the third question, C. What air temperature must be used if the piece were to be cooled down to 5 degrees centigrade in 30 minutes? So now he is saying that T infinity is unknown in this question. The question number C, T infinity is unknown. Again, you write this formula, T minus T infinity by T naught minus T infinity is equal to e power minus biot into Fourier. Okay, this is the formula. And in the question, what he is giving, the time is 30 minutes, he is saying. And then the temperature is giving as 5 degrees centigrade. And he is calling this temperature if the piece were to be cooled down to 5 degrees centigrade, then this temperature is T according to our nomenclature. So this is your 5. Okay, so he's asking you to find out T infinity. Now the biot into Fourier, anyways, you have to substitute this 1.77 into the 30 minutes here. So it will be like this: 5 minus T infinity by 25 minus T infinity is equal to e power minus 1.77 into 10 to the power of minus 3. You have done this already. The time is now 30 minutes. 30 into 60 you have to substitute. So in this T infinity is unknown, calculate it. Tell me what is the RSS value, RHS value first. On RHS, what is the value? Tell me first.
Sir, the diameter of the piece will be different, no, sir. And in the question they given
What ma?
The diameter of the piece are different in the question, no sir.
It is 8 mm, no?
Yes, sir.
The same value is taken, no? Here throughout. Can you see this?
Okay, sir.
Here it is 8 mm. It is taken as 8 mm throughout the question. Okay.
Okay, sir.
So no change.
Sir, is it 4.077 degrees?
You are directly telling T infinity, isn't it?
Yes, sir.
4.77 degrees centigrade. Okay. Okay. You solve for it. The T infinity is the only unknown, and he will get this value as 4.77 degrees centigrade. Okay. So this is a story, and from this you can understand one practical thing. Okay. In question A, you got the time. The time is 31 minutes. Okay. And here the cooling down temperature is from 25 degrees centigrade to 2 degrees centigrade, and the atmosphere temperature being 1 degree centigrade. So this is atmosphere temperature, this is temperature drop, and this is time. And let us see the second case. In second case, what is the time? 10 minutes is the time. And what is the delta T? It is from 25 degrees centigrade to 9 degrees centigrade. And here also the atmosphere temperature is 1 degree centigrade. In question number C, the time is given, it is given as 30 minutes. And the temperature drop, it is given as 25 degrees centigrade to 5 degrees centigrade. And the atmosphere temperature is 4 degrees centigrade. Okay. See, you can consider any two cases. Okay. You can consider any two cases, this one, and you can draw so many conclusions here. See, here, if I take A and B, what can you conclude from this? What can you conclude from this? See, for the initial drop till 9 degrees centigrade, it is taking only 10 minutes. For the remaining drop, you see, it is taking almost 20 minutes. Okay. So the temperature drop is faster during the first 10 minutes, and in the remaining 20 minutes, the temperature drop is slowed down. Okay. So is delta T is faster till 10 minutes. Okay. And after 10 minutes, the rate of cooling has decreased. See, you can understand it very easily. You have any hot body with you, something you are eating, something like peas. Okay. If that is the case, the temperature drop will be very fast if the delta T is very high. The delta T here, if you take, initially it was 25 to 1 degree centigrade. So that's why the faster heat transfer will happen. Whereas here it came to 9 degree centigrade. 9 to 1 degree centigrade is less the temperature difference. So obviously the cooling rate will be slowed down. Okay, it will be hampered. So that's the point. And let us consider these two now. Let us consider uh, no, the first one, the question number A and the question number C. Let us consider and compare what can we understand from this. See, in A and C, the time is same. The temperature uh, drop is different. See, the temperature drop is significantly influenced by the atmosphere temperature. Okay, it cannot go beyond the atmosphere temperature. Since it is 1 degree centigrade here, it has come till 20 degrees centigrade here. Since it is 4 degrees centigrade here, here it came till 5 degrees centigrade. So what is the meaning of it? The meaning of it is the temperature of the given body cannot go less than the temperature of the atmosphere. So from this, what you can say is temperature of a body cannot go beyond the temperature of atmosphere. See, these are all simple things, yet you are trying to understand from this particular example of peace. Okay, so that's the thing. And let's move on to the next question. Before we move to the next question, let me put forward a simple question to you here. See, so far what you have done is you have taken a small p. Okay, this is p and it has 8 diameter and you are calling it as lump. Okay, now what I will do is I will take a big thing, maybe something like potato or brinjal, whatever you call it. Potato. Okay, it has maybe 5 centimeter dia, something like that. Can you call it as lump or not? I hope my question is clear to you. Potato is boiling in water. Okay, can you consider that particular system as a lump, or potato is kept in air? Okay, hot potato is kept in air. Can you consider this as a lump? That's the question.
No, no, sir.
Huh?
It should have higher thermal conductivity too.
Yeah, here P is also having less
But
thermal conductivity, isn't
it
it?
has less volume.
Hmm. See, the point here is the Bayard number
Temperature.
will be less than zero point 0.1. Okay, that should be satisfied. And here that cannot be satisfied. See, the, what is the other way of saying the Bayard number less than 1 is temperature is uniform throughout. Temperature is uniform throughout the body. Whereas here, can that happen? It will not happen. Temperature is not uniform. So this cannot be considered as a lump. Got the point? So the lump doesn't depend only on the thermal conductivity. Whether you consider the thing, the given case as lump or not, is not depending purely on the thermal conductivity issue. Okay, you have to check with the bat number if possible. If it is not possible, check with common sense whether the temperature is uniform throughout the body or not. If that can be done, if that can be perceived, you can consider whatever the case it might be. Right. Let's move on to the next question. Look at this question. This is a real time case again. Here you have a human body, and this human body is considered to be a dead body here. Okay, so what he's saying that he's saying that there is a dead body, and once you have a dead body and you have found it at 5 a.m. in a room, and you want to know when did the person die. Okay, that's the question basically. Okay, the temperature of body is measured to be 25 degrees centigrade when found, and you wanted to know time of the death of a person. Okay, when did that person die? That's the question. When did the person die? Died, you can say. Okay, so see here, when he was alive, his temperature will be 37 degrees centigrade. When he was found dead, the temperature 37 degrees is given in the question here. The living person is given as 37 degrees centigrade, and when he was found, the temperature of the body is found to be 25 degrees centigrade. And what he is saying is, using the lumped parameter system analysis, you solve this problem. He is saying, so um, he is asking you to consider this as a long cylinder. Okay, that is the whole human body he wants you to consider as a cylinder itself. Okay, so this is a cylinder. It is having so and so length. The length of it is 170 centimeter, and the diameter is 30 centimeter. Yeah, 30, 170 is given. So what is saying that the 72% of the mass of the human body is taken by water. So you consider simply this is a water equivalent to person. Okay, that's a approximation, but let us see. So density is given. Density is equal to 1000 kg per meter cube. The CP, all these are, and again, you know, the properties of water. These properties actually you should remember. Okay, by heart. You should know the density, the CP value, and K value of water should be known to you. You should by heart. Okay, so what you have to do, you have to find out the time. So that's the thing here. So for that, first you need by it into Fourier, because you need t minus t infinity by t naught minus t infinity is equal to e power minus of Bayat into Fourier, Bayat into Fourier. This is equal to HLC by K into alpha T by LC square. Okay, in this everything is known except LC square. Okay, so find that LC first. So the LC is equal to the volume by area. So how do you find out the volume and area here? See, the volume is the pi r square into L. The pi r square to L. Area. When it comes to area, you have 2 pi RL, that is, this 2 pi RL is this one, this area. Also, you have this area and this area. So you have to add this area 2 times. So plus 2 times of pi r square. I have to write. Okay. So then tell me what is the r value here. See, maybe pi can be cancelled. All this pi you can take it out. R also cancelled out here. So what you have is R into L by 2L plus 2R. So that is R into L by 2 into L plus R. That is a formula, and a formula which you can remember. Anyways, the R value is 30 centimeter, 30 into 10 to the power of minus 2 by 2, because diameter is given as 30 centimeters, and the L is 170 by 2 into the L plus value. L value is 170 and R value is 30. This is also should be converted to centimeters. So you tell me what is this LC value now.
6.89.
Huh?
6.89.
You are telling it in,
Zero
you tell me in meters.
0.06.
0.0689.
Meters. Okay, that is the LC value. Now you find out what is Biot. HLC by K is equal to H value is given as 8 and the LC value is 0.0689 by the K value is 0.608. So tell me what is Biot value. Same time Fourier alpha T by LC square. Alpha value is K by rho CP into the time as unknown anyways by LC square. The K value is 0.608 by the rho is 1000. The CP is 4180 and the LC is 0.0689 square into T. Tell me what is Biot first.
0.9.
0.9, huh? Yeah, 0.92. The Fourier value is something into T. What is that something, you tell me.
3.064 into 10 power minus.
Sir, Biot is greater than 0.1.
I'll discuss about that. 3.064 into 10 to the power of
Minus 5.
minus 5 into T. That is your Fourier. Now let's move on to the formula, that is T minus T infinity by T naught minus T infinity is equal to e power minus Biot in Fourier. The question, T infinity is given as 20 degrees centigrade. This is 20 degrees centigrade. This is also 20. When the person is alive, the temperature of the body is 37. When he is found dead, it is 25 degrees centigrade. So substitute the values. 25 minus 20 by 37 minus 20 is equal to e power minus 0.92 into 3.6064. into 10 to the power of minus 5 into t. So apply ln on both sides. Get the value of t. Tell me what is the value of t.
Two four nine six four 0.127.
No,
24964. Is it right, sir?
no. In seconds you are saying,
Yes, sir.
did you use ln only?
Yes, sir. Yes.
Make sure did you use ln or not. Or check with this Fourier. Fourier is calculated properly or not. Sometimes Fourier's calculation it will do mistake. This whole square should be taken. This might have missed. Check it.
Fourier is right, sir.
Or sometimes minus people will miss. This minus is very much important. Many times people will miss it while calculating it. Minus.
Fourier 3.064 into 10 power minus 5. That's right, sir.
That is fine. Tell me what is the time value?
64.
T. See what I have with me is 44,057 seconds. Okay, these
12
many
hours,
seconds.
25 minutes. 12 hours something.
12 hour 24
Minutes.
minutes. Okay, so you found it at 5 a.m. So this is found at. So you have to go 12 hour 24-minute backward to find dead time. Is dead at what is the time? 12 hours before. That is at 4:30 p.m. around.
436.
36 p.m. So that person is dead at 4:36 p.m. and he is found at 5 a.m. You got it? So that's how I have found out a person is dead. See, this is a procedure followed in forensic sciences to find out the death time. See, here it is very important to understand that it is an approximate death time. It is not the exact death time, it is an approximate death time. See, there are many approximations considered in it. And one approximation is that you have considered that it is a water, okay, which is not true. And the second approximation is that the temperature of atmosphere is not varying. See, in a real time case, the temperature of the atmosphere will be varying with respect to time. Okay, throughout it will not be 20 degrees centigrade. Especially during night, it may fall below 20 degrees centigrade. This is one more approximation that we have considered. And one more thing is, it is considered as lump, whereas it should not be considered as lump. Strictly speaking, it should not be considered as a lump because the Biot number is not less than 1, 0.1, sorry. Biot number should be less than 0.1 to consider. But here in the question he has clearly mentioned that you have to solve this problem using the lump parameter system. That's why you have used the lump system. Got it? So even though sometimes a Biot number less than 0.1 is not achieved also, if it is given in question, you can consider it as a lump and solve the problem. Okay, I hope you got the point. How this particular thing can be used in finding the approximate death time of a dead body in the forensic sciences. I hope it's clear. You have any questions at this level?
No, sir.
Right. Thank you. Let's move on. All these things are not correct actually. That you should be given. Right. Uh, let's move to the next problem. Here. This is your problem here. This is one more example. So this is an example of an iron. This is a 1000 watt iron is there here. This problem is given here. He is saying that it is 1000 watt iron. So what you can do is Q is 1000 watt. That is what is given first, and the thickness is given. Thickness is 0.5 centimeters, and aluminum, its properties. This is not P. This is rho density. Kg per metric cube. This alpha. All the things are given. Rho is given. Cp is given. Alpha is given. All the things are given, and area is also given. And the area is 0.03 meters square, and the temperature initial is given as 22 degrees centigrade. It's given here, and he's saying that this is also equal to the atmosphere temperature. If this is same, the denominator T minus T infinity by T naught minus T infinity is equal to e power minus biot into 4 here. This is the question. See, if these two are equal, no, the denominator is turning out to be 0. This is turning out to be 0. So if that is the case, how we are going to solve it? Let's see. Taking the heat transfer coefficient at the surface H is equal to 12 watt per meter square Kelvin, and only 85%. See, if this is 85%, what does that imply is Q actual has to be taken as 0.85 into 1000 you have to take. So that will give you 850 watts. 850 watts will be your actual Q. Determine how long it will take. So again is asking you to find out the time. Time, what is the value is asking, and the temperature of the plate to reach, that is this T is given as 140 degrees centigrade. The temperature in the numerator is given as 140 degrees centigrade. If that is the case, how you are going to solve for time? Okay. First thing, let us discuss how to go for this denominator 0. Okay. The denominator 0, how to get that? You have to eliminate this 0 here. So for getting this expression, how you go about this? See, this is actually Q is equal to HA T minus T infinity. This expression is nothing but this expression. So what I can write is T naught minus T infinity is actually Q by HA. This is what I can write. Q by HA I can write. So I have Q as 850. Q actually have to take anyways by the H value, it is 12, and the area value is 0.03. So we can take this value and you'll get the denominator. So once you are done with the denominator, you can think of the remaining things now. The remaining things are like the numerator. For getting the numerator, T minus T infinity, it is simply 140 minus the T infinity is 22 degrees centigrade. So you know the numerator also. Let's come to this Biot into Fourier now. Coming to this Biot into Fourier, what you need is LC. HLC by K into the alpha is given in question, T by LC square. T you have to find out. T anyways is unknown. You have to find out. Alpha is given. H is given. K is given. Alpha is given. LC should be known to you. So how do you get this LC? Let's calculate the LC. The LC value, you know it as volume by area. Okay. Now, what I'll do is I'll write this volume as L into A by area. Anyways, I will leave it like this. See, this L is nothing but the thickness. Okay. See, if you have a plate here, this plate you can see here. Okay. This plate is having so and so area. Area is known to you, and if you want its volume, you have to multiply the area with its thickness. So thickness, that will be giving you the volume. So this one is thickness. So the thickness is clearly mentioned in the question as 0.5 centimeters. So substitute that. Area get cancelled. 0.5 into 10 to the power of minus 2 meter you will get. That is your LC. Now that you know your LC, you can substitute everything into the question and solve it. So can you do that? Is it clear? I will leave it here for you to do. So what you have ultimate, okay, this one let me do. The H value is what is the H value? It is 12. The LC value is 0.5 into 10 to the power of minus 2 by K. The K value is given in question or not? It need not be given actually. Yeah, K is not given. So the alpha you can write as K by rho Cp into the time is unknown anyways. Here I will write HLC by K itself. ILC square, this goes, this K goes. So this will give you H by H into rho Cp LC into time. So that is equal to 12 by right, what is the density given, and everything you can substitute, you will get something into T, and then T minus T infinity by T naught minus T infinity is equal to e power minus by it into Fourier. In this expression only unknown will be T, and you can calculate it for yourself.